So in this video, we're going to combine some of the work that we've done in past videos to factor polynomials. And so here are the things you're going to look for. Here's some guidelines for factoring. You always want to look at the terms in the polynomial and see if you've got a greatest common factor. And if you do, if you have a greatest common factor that's bigger than 1, then you want to factor out the greatest common factor first before you start unfoiling or looking for patterns in the polynomial. So step 1 is going to be factor out the greatest common factor if possible. So you want to always check for that. Okay, once you factored out the greatest common factor, then you want to see how many terms your polynomial has, because you've got some tips on how to factor depending on how many terms the polynomial has. So step 2 is if the polynomial has 4 terms, then we're going to do factoring by grouping. And we've done a video on that, but we'll have some examples below. If the polynomial is a binomial, then I want you to try one of the following. If you have a binomial and you know that you've got a difference, subtraction, a difference, and your 2 terms are perfect squares, then you've got the difference of 2 squares. And as you know from a previous video, we factor that as a plus b, a minus b. If you've noticed that you have squares, but instead of having a difference, you have a sum, so you have an addition here, then this binomial cannot be factored. It cannot be factored, and so we call that prime. Okay, so the sum of 2 squares is prime. Cannot factor that. Okay, put that in your notes, because sometimes students forget. Sum of squares cannot be factored. Okay, if you have a polynomial that's a trinomial, then you're going to check for a perfect square trinomial. So you have the 3 terms, and here's a review on how to know if you've got a perfect square trinomial. You check out what you squared for the first term, so whatever you squared here, and then you check that the third term is a square, and you notice what you squared for the third term. You multiply those 2 expressions, those 2 a times b, and if you double that and you get this middle term, then you have a perfect square trinomial. So if you have twice a times b, double that in the middle, then you've got a perfect square trinomial, and as you recall from previous videos, that would be factored as a plus b squared. Same thing if you have same pattern but with a negative middle term, then you're going to factor it as a minus b squared. So these are the perfect square trinomials, and we had a video on that. So if you haven't watched that, feel free to do that, okay? Now, if your trinomial is not a perfect square trinomial, then we're going to apply foiling or grouping. So we're going to do the trial and error foiling that we've done before. All right. Finally, once you've factored your polynomial, you always want to check to make sure that the polynomial is completely factored. What that means is look at your factors and see if any of those factors factor again, because sometimes some of those factors can factor more. So you want to check for that. All right, let's do some examples here. Factor each polynomial completely. All right, so here we have 5x cubed minus 20x squared plus 25x. That's our first polynomial. And remember step 1? Step 1, we're looking for a GCF, greatest common factor. So you're going to look at all 3 terms, and do they have something in common? And if you said yes, you are right, because all 3 terms have a 5 and an x factor in common. So we're going to pull out the 5x. So the GCF is 5x. So you're going to write 5x and then a parentheses, and now what's left when you pull out a 5x. Well, 5x from 5x cubed, that leaves us an x squared, right? Because 5x times x squared is 5x to the third. Okay, 5x pulled out of negative 20x squared leaves us a negative 4x. Because 5x times negative 4x gives us negative 20x squared. Okay, 5x pulled out of a 25x leaves us a 5. Because 5 times 5x is 25x. So whatever you pull here as the GCF, whatever you pull here, you should be able to, in your head, distribute, multiply times your leftover terms inside the parentheses, and you should be right back where you started from. That's how you know that you've done this factoring part right. Okay, so that's step one. Step one, we pulled out the 5x. Now we're going to leave the 5x out here, and we're going to look at this trinomial that's in here. And so again, we have a trinomial. There are 3 terms. Is this a perfect square trinomial? Well, if you said no, you're right. And how do you know? Because this third term here, this 5, that's not a perfect square. It's not in our perfect square table. Okay, remember we made that table in the last 2 videos. So if you don't have that handy, go pull it out and look it up in your notes. So 5 is not a perfect square, so we don't have a perfect square trinomial. So we're going to unfoil. We're going to do trial and error. And so I'm going to put 2 parentheses. And then here and here, 2 numbers that multiplied x squared. So we have an x and an x. We know that because we have a positive third term and a negative middle term, that our signs are going to both be negative. And then we want 2 numbers that multiply to 5 and then add up to 4. Well, let's see. The only way to multiply to 5 is 5 and 1. And if we use 5 and 1, what's our middle term going to be? Well, the inners would give us negative 5x. The outers would give us negative 1x. So that would be negative 6x, which is not what we have here. So guess what? This trinomial doesn't factor, right? Because there's no other way for us to factor 5 but 5 and 1, and these signs have to be negative. So what does that tell you? That tells you that we cannot use this. And so the completely factored form of our original trinomial is just pulling out the 5x. But see, we have to check. You can't assume that you were done right here at this step. Okay, so here's our final answer. Let's try the next one. Okay, we've got another trinomial, 6x squared minus 12x plus 8. GCF, is there a greatest common factor that we can pull out? If you said yes, you're right, because notice that all of these terms are even. So there's a 2 that we could pull out. So we're going to pull out a 2. That's going to leave us, well, a 3x squared here, because 2 times 3x squared is 6x squared. And then here in the middle we have a negative 6x. 2 times negative 6x is negative 12x. And then our last term is a 4, because 2 times 4 is 8. So notice that we always check that in our head that whatever we left in the parentheses here, when you distribute the 2, you get back what you started from. Okay, we're this far now. What do you think? Do you think that this trinomial factors more? Shall we try it? Okay, it's not a perfect square, right? Because although this is a perfect square, the 3 here is not. So we don't have a perfect square trinomial, which would mean that we would try our foiling or our trial and error. And the only way to get a 3x squared is 3x times x. Now, 4, we have two possibilities. We could either use a 4 and a 1, or we could use a 2 and a 2 and see if any of those would work to get our 6 middle term. And, oh, what are the signs? Well, this third term is positive and the middle term is negative, so we have, again, 2 negatives. Now, Whatever I put here is going to be affected by this 3. So we better put small numbers here, right? Because we're only trying to get to a 6. So if I put the 1 here and the 4 here, my middle term is going to be negative 4x here and then negative 3x here, right? So that is going to give me a 7. The inners and the outers gives you a middle term, so that's going to give me a 7. That's not what I want. So guess what? We got to try something else. Okay. Well, the only other thing we can try is that 2 and 2, and if you see something bad with that, you were right, because right here the outers is 3 times 2 gives us the 6, but we're going to add this other 2, which would make the middle term negative 8, and that's not what we have here. So guess what? Again, we were done factoring at this step. So that is our final answer right there. Okay, they're not all going to be that way, so don't think they are. Okay, let's go to the next one. All right, this time we have a binomial, 2 terms, greatest common factor, x squared. So we're going to pull out an x squared. That's the greatest common factor. That's going to leave us with an x squared minus 9 binomial here. Again, in your head, you can see that if you distribute this x squared, you're going to be back where you started from. So that's what. So this is how we pull out the greatest common factor. Now you hopefully recognize this binomial. Yep, it's the difference of 2 squares, because you know 9 is a squared. What did you square to get 9? You squared 3, right? And so this is 3 squared. And of course, x squared is x squared. So, and we have the difference, we have the subtraction. So as you know by now, that's going to factor as x plus 3, x minus 3. And then do a quick check. Can we factor x plus 3 or x minus 3 further? No, we can't. So this is your final answer right here. Don't forget when you write your final answer to include the x squared greatest common factor that you pulled out in the first step. Otherwise, you will probably get partial credit but not full credit from your teacher. Okay? All right. Here comes the next binomial. 48x cubed minus 3x. Is there a greatest common factor that we can pull out? Yes, there is, right? We can pull out a 3x. Now, if we pull out a 3x, 48 divided by 3 is 16, so we get 16x squared here. And now notice how we pulled out the entire term from the second term, right? So the 3x is out here, and what's left here? Now, a lot of students then will just close off this parenthesis and be done, because they figure, well, I pulled out this 3x, so there's nothing left. But remember how we always check mentally to see if when we distribute, if we end up with what we started, and here we would only end up with the first term, right? We'd be missing that negative 3x if we distributed the 3x. So in a case like this where you're pulling out a complete term, what you're going to do is kind of like hold the spot with a negative 1. And you can see that if you distribute 3x now, 3x times negative 1 gives you your negative 3x term back. So this is how you pull out your first 3x. Okay? Now, see that binomial right there? Can that be factored further? If you said yes, you are right, because you hopefully are recognizing now the difference of 2 squares. 16x squared is 4x squared, right? And 1 is a perfect square because 1 is 1 times 1. 1 is 1 squared. So we're going to put our 2 parentheses here, and we're going to write 4x plus 1, 4x minus 1 as the factored form of 16x squared minus 1. And then remember always to bring down your greatest common factor for your final answer. Now, could any of these be factored more? 4x minus 1 and 4x plus 1? No, they can't. They're as factored as they go. So This is your final answer. Right? This whole thing right here. Cool. Let's go to the next one. Got a couple more for you. Okay, now we're back to our trinomials. Now, if you are looking at this and saying, well, there's no greatest common factor that I can pull out, you're absolutely right. Now, these terms don't have anything in common but a one factor, and you're not going to pull that out. So we're ready to go to step 2. And step 2 says, look how many terms you have. Okay, well, we have three terms, and so it's a trinomial. Is it a perfect square? Well, let's check. Is x to the 4th a perfect square? Well, you should say yes, because x squared is x to the 4th. Okay? And you know 100 is a perfect square because that's 10 squared. Okay. Now, do we have the right middle term in order to factor this as a perfect square trinomial? And just remember that the middle term, how you get that is you multiply the x squared times the 10. So that's 10x squared, and then you double that. You multiply that twice that. So 2 times 10 is 20x squared, which is not what we have here for middle term. So this is not a perfect square trinomial. Not a perfect square trinomial. Okay, not a perfect square trinomial. But does that mean you stop trying to factor it? No, because that means we're now going to try just our foiling method. And we'll put our x squared here and our x squared here. And we know we have a positive here and a negative middle term, which means that both terms would be negative. Now we're going to look for two numbers that multiply to 100 but add up to 29. And there's many ways to factor 100, but hopefully you are remembering your dollars, right? 4 quarters make $1, so 25 times 4 is 100. And guess what? 25 plus 4 is 29, so cool. All right, we got that on the first try. You're not done, because these binomials, if you recognize them, you will know that they factor further. They are difference of squares. Both of them are, aren't they? 25 is a square, so is 4, and of course the x squared. So we're going to continue factoring. They both factor further. And here we'll have x plus 5, x minus 5 for the x squared minus 25. And here we'll have x plus 2, x minus 2 for the x squared minus 4. Now are we done? Yes, because none of these binomials factor further. Okay, did you follow that thought process? Hopefully that will help you. Oh, it looks like we have 2 more. Okay, so let's look at this binomial, which has a bunch of letters. What's the greatest common factor? Well, if you said 4AB, you're correct. 4 goes into 16 and 36, and they'll both have an A and a B. So pull that out. Now that from here, that will leave us with a 4A squared. Now remember that in your mental check, you're multiplying these two terms to make sure you are back here. And 4AB times 4A squared does give us back our 16A cubed B, right? Okay, minus. Now what are we left with when we pull out the 4AB from this 36? Well, we have a 9B squared. Okay, and again in mental math, mental check, 4 times negative 9 is negative 36, and then we get AB cubed. So that's cool. We got the first step done. Step 2, does this binomial factor further? Binomials, is it difference? Is it the difference of 2 squares? Hopefully you recognize that yes it is. What did you square to get 4A squared? Well, 2A, right? This is 2A squared minus. What did you square to get 9B squared? You squared a 3B. Okay, so this is definitely the difference of 2 squares. Now, don't leave this answer like this. This is not the complete factor form. So we're going to keep going. So this 4AB tags along from the original GCF. And then here's your 2 parentheses. And how you factor that difference then is 2A plus 3B, 2A minus 3B. And what about these binomials? Do they factor further? If you said no, you're right. So this is your final answer. Okay, very good. Okay. All right, one more, and we are going to look at these four terms. Greatest common factor is 2. So out comes the 2. Leaves us with an x to the 5th minus 4x cubed plus x squared minus 4. Very good. Now, notice this time we're left with 4 terms. And when we have 4 terms, that's when we use grouping. So how we use grouping, here's a review. You group 2 terms and 2 terms with a plus in between. So we're going to group the first 2 and the last 2. Okay. And let's see. Well, from here we can pull out an x cubed, can't we? Okay. Now this 2 is hanging on. Okay, so kind of, let's do this inner parentheses first. Okay, so here we have an x cubed, and that's going to leave us with x squared minus 1. Oh, excuse me, x squared minus 4. Left over here when we pull out the x cubed, remember mental math where you check, and when you distribute, you do get these 2 terms back, right? Over here, we have nothing in common. So the greatest common factor is a 1. Let's go ahead and write that 1. Okay. X squared minus 4. All right, fantastic. Okay, so now to complete the grouping, we're going to pull out this x squared minus 4. The 2 is still hanging on. And so we have an x squared minus 4 times an x cubed plus 1. Okay, very good. So can we factor this further? Well, if you recognize this binomial as a difference of 2 squares, then cool. Then you know what to do, right? That's going to be x plus 2, x minus 2. Now this binomial here is up to whatever, it's up to you in whatever class you are in. Now in the class that's following these videos, we are not going to do this type of binomial. This is called the sum of 2 cubes. Okay, so we would stop here. But for some of you may know how to factor the sum of 2 cubes. And so for those of you that know, you know that there's going to be a binomial and a trinomial. And that, again, kind of like with the difference of 2 squares, what did you cube here? Well, here we cubed the x, and here we cubed a 1. Okay, and so this binomial is x plus 1. And then the trinomial is going to be x squared. You square this guy. The middle term is negative. Then you multiply those 2, which is x. And then you add the square of this guy, which is 1. So that's for those of you that are watching this video that who's in your classes you have talked about the sum of 2 cubes. But for those of you that haven't, then you would stop here. Okay, you would stop at there. Okay, and you know which group you're in. All right. Good review, everybody.